Okay, we're back. Hold the presses. So without using a calculator, this is what they want you to do. Look at this picture, pi over 3. Okay, so remember, and we're on the unit circle. That means that this equals 1. So, and here we're in the Cartesian plane. What are these 2 points? Well, this is x and y, whatever they happen to be. We know that the cosine of pi over 3, which is the same as the cosine of 60 degrees, is 1/2. And the reason why we know this is because I actually kind of asked you to memorize it, and there's certain ones you just want to know. So what is the sine of pi over 3? Well, just supposing you didn't know, there's a way that we can figure it out, which I'll show you. I'll put these in here. So cosine of pi over 3 is 1/2. We know that r is 1, so here's your x divided by 1, there's your r. So this x coordinate is 1/2. This is the nice thing on the unit circle. Whatever the cosine is on the unit circle, that's the x. Similarly, whatever the sine is, and this is going to be the y, I claim it's going to be the square root of 3 over 2. I'll prove that. These are things that happen so often that you just want to know these. You really do. It'll make your lives much easier. Supposing I remembered cosine of pi over 3 was 1/2, but I didn't remember that sine pi over 3 was 1/2, or square root of 3 over 2. How would I figure that out? Well, I know for any angle that cosine, so in this case pi over 3 squared plus sine pi over 3 squared is equal to 1. That means that 1/2 squared plus sine squared pi over 3 is equal to 1. That means this is 1/4 plus sine squared pi over 3 is equal to 1. I'm going to subtract 1/4 from both sides, and I'm going to bring it up over here and put it in blue. So that means that sine squared of pi over 3 is equal to 3/4. Now, I'm taking the square root of both sides, and this is something that never gets emphasized enough in algebra. In general, whatever your generic function, x squared, the square root of whatever function this is squared is, by definition, the absolute value of that function. So this is, incidentally, I should spend a second on this. The square root of 4 is 2. It's not, the square root of 4 is not plus or minus 2, even though that minus 2 times minus 2 equals 4. This is called the principal square root. The reason that when you solve quadratic equations that you get 2 answers is because of this definition. Suppose we're just going to do this. Suppose we have x squared is equal to 4. Then the square root of both sides, the square root of x squared is the absolute value of x is equal to 2. This is where you get x equals 2 or x equals negative 2. The reason I went into such detail about that is, for some reason, nobody ever really explains that, and I don't know why. Incidentally, this is called the principle of square roots. Okay. So, why did I yammer on like that? Well, taking the square root of both sides of this means that the absolute value of sine pi over 3 is equal to the square root of 3 over 4 is the same as the square root of 3 over the square root of 4. This is the square root of 3 over 2. That means that the sine of pi over 3 is equal to plus or minus the square root of 3 over 2. You'll notice the sign has come into this formula here. And what we have to do now is just think about, this is where knowing the quadrants is so important. We know for a fact we're doing this right here. Y is positive here, so it must be positive, right? Okay. And right now you're probably saying, geez, this is a lot of work, considering I could have just punched it into my calculator. This is true. However, when you get to Cal 2 in particular, a lot of times there's not going to be numbers, and you're not going to be able to use your calculator like you are on problems like this. And maybe in the next couple days, next couple lectures, I'll show you some hypothetical problems that you might be working. Anyway, so we have this, and I don't think we need this picture anymore. Okay, so we have this, and we were supposed to figure out what all of the 6 trigonometric functions were at pi over 4, 3 radians. I need to figure out what the picture is, and here it is, right here. So once again, we're on the unit circle, and this is all the way across here is 4 pi over 3. I need to know what are the numbers here. Well, clearly x is just negative here, so this is going to be negative 1/2. And also y is negative here, so this is going to be negative square root of 3 over 2. And now it's easy. Cosine x, which in this case is going to be pi over 3, 4 pi over 3 is just going to be the x coordinate, or this divided by 1, because r is 1. So this is just negative 1/2. The sine of 4 pi thirds, well, this is negative square root of 3 over 2. And I just realized this is pretty ugly. That's better. That means that the tangent of 4 pi thirds is equal to y divided by x. It's going to be, I'll write it down, negative square root of 3 over 2 divided by negative 1/2. This is the same as the square root of 3. Remember that two negatives cancel. Division by a fraction is the same as multiplication by the reciprocal. It cancels out. Now the rest of them are easy. Secant 4 pi over thirds is this upside down. This is just negative 2. Cosecant of 4 pi thirds is this upside down. This is negative 2 over the square root of 3. Let me comment here. Back in the days when the dinosaurs roamed the land, they would not allow you to have a radical in the bottom. Now that there are calculators, I can't see why anybody would care. But in the old days, they would make you do this. Square root of 3, square root of 3. This is negative 2 times the square root of 3 over 3. I'm perfectly fine with this answer right here. Okay, so the last thing that we have to do is figure out what cotangent is. Cotangent of 4 pi over 3 is just this upside down. This is really this over 1, so this is 1 over square root of 3. All of this can be done by constructing a simple picture. You really want to have these basic things in your storage, in your mind. Can you function without them? Yeah. I would take some steps to memorize these basic ones. Okay. Another homework problem was we were dealing with average values of functions over intervals. And you'll remember, what is the average value of a function? The average value of a function is given this. Suppose that, well, in general, the average value of a function is f of b minus f of a divided by b minus a. Incidentally, what is this? If this is the picture, this is the function, here is a, here is b, this is a hypothetical picture. This is f of a, this is f of b. Well, what is this? This is what you used to call slope. This is the slope of this line here, right? So the average value is just the slope over this particular interval. Here's the run, which is the top, and here is, oh, I'm sorry, me stupid. Here is the rise going up here, and here is the run. Okay, and with that blunder, we'll be back in a moment.